questions on the homework? 4.1 or 4.2? I haven't had a chance to look at it yet, but that's fine. Yes. So far, what we've done with Chapter 4 is define what is a higher degree polynomial function, classifying it, stating it, or writing it in standard form, and evaluating is kind of, in essence, what we did with 4.1. 4.2, we went over addition, subtraction, and multiplication with these higher degree polynomial functions. The only operation we haven't done so far is division, dividing higher degree polynomial functions. Now, there's two ways that we can divide higher degree polynomial functions. One of them is long division, and the other is synthetic division. Long division or synthetic division. Now, this is on that first page. You do not have to write all this here, because all this is saying is when you divide a polynomial, f of x, by a divisor, d of x, our quotient, we're going to have the whole part, the part that comes out evenly, and if we have a remainder, we're going to put it over what we're dividing. This is just kind of dividing in a nutshell. And we're going to use long division to divide these polynomial functions. Now, in some ways, it's a little nice. Some ways, it's not as nice as doing long division with numbers. It's been a while since you've had to do long division. But the nice thing with long division is it's about 3 steps that we repeat again and again and again. So when we look at this here, x cubed minus x squared plus 2x plus 8, I did change the problem just a little bit because we're at the top of the back of the first page. Because instead of negative 2x, it's positive 2x. Instead of negative 1, it's plus 1. And I did that on purpose just because how the numbers work out. Works out a little nicer if it's plus 2x and plus 1. Okay. Now the first thing we need to do is actually set the problem up. With long division, we have the house. There's different ways that we name it, but we start out with this here. What's being divided? Our x cubed minus x squared plus 2x plus 8 goes inside. The divisor, what we're dividing it by, x plus 1 goes on the outside. Questions on how we set this up? Yes, sir. So what comes first goes inside, and what comes second, what comes after the division goes outside. What goes before the division goes inside, what comes after it goes outside. If they wrote it on top of each other, you don't have to write this. As a division, what's on top goes inside, what's on bottom goes outside. Because we're just saying numerator divided by denominator. Okay. Questions on this so far? Now, unlike dividing or using long division with numbers, synthetic division, or not synthetic, long division with polynomials, it kind of works about the same but a little different. Because normally we look at the first number, first 2 numbers, see how many times the one outside goes into it. Here, we're wanting to eliminate whatever the first term is out each time until we can't anymore. Until the degree of what we're dividing is bigger than what's being divided. Now, the first main step is seen in eliminating that first term. And our first term is the x cubed. We want to get rid of it. We want to simplify it out. Now, the first term outside is what? X. And we want to use that x to somehow eliminate x cubed. Now, to do that, the first main question, and I'm going to ask this again and again today, what do we need to multiply x by to turn it into x cubed? What do we need to multiply x by to turn it into x cubed? x squared, because x squared is what we need. And we're going to multiply the x squared by the x plus 1 to get that x cubed to go away. Stuff's going to happen with the rest of it, but that's the main first step. And we're going to distribute the x squared. Now x squared times x is x cubed, like we want, because when we multiply like bases, we add the exponents. Now we still have to multiply through. X squared times x is plus x squared. Questions on this so far? Because again, the main thing is we want to eliminate that first term. Now we're going to take this expression and write it underneath. And we want to make sure we do line the like terms up. So we have x cubed under x cubed, the x squared under the x squared. Yeah. And again, you might want to write that off to the side, the x squared times x plus 1, because we're going to be going down. We have multiple steps underneath it. Questions on this so far? Are we good with how this is set up so far? Now the next step, the next part is going to be to subtract. We're going to subtract straight down. So our first thing we have is x cubed minus x cubed is 0. Yes? They divide out. That's what we want to have each and every single time we do this. We want that first term to cancel out. Let's see what happens to the rest of the terms. Negative x squared minus x squared. Negative 1 minus 1 is negative 2 x squared. We don't have any other terms, so we finish subtracting. Questions on what we've done so far? We're almost done with the first step. And again, once we get the hang of this, it's going to go a lot faster, but I want to make sure we're good with this here. Yes? We understand everything so far. Last part of the first step is to bring the next term down. We're going to bring this next term down, which is our plus 2x. Oh, sorry. I meant to put that up there, the x squared. One more time. Because our final answer is going to be what's on top of this bar. I meant to put the x squared up there, I just forgot. Okay. Questions on what we've done so far? Because that is the first step. So the x squared on top, I should have done that from the beginning, is going to be the final answer. So we're saying what times x gave us x cubed? Well, that was x squared. Yeah, this is going to be our answer. So the x squared is part of our answer.
So that's where you.
Yep. Yes. Yeah, no, it's part of the answer. I just forgot to write it there. So we good with the first part? Yes? All right. Because now we're going to essentially do that all over again. And that's really all there is to this here, because now our first term is what? Negative 2x squared, yes? So we're going to ask the question again, what do we need to multiply by our x, that first term, to give us negative 2x squared? Well, what's the number in front of x here? 1. Yes, it would. So what do we need to multiply by 1 to get to negative 2? Well, it's negative 2. And for x to become x squared, we need x. Yes? All right, well, I'm going to come over here and do the same thing again. We're going to do negative 2x times x plus 1. Negative 2x times x is negative 2x squared. Is that the first term we wanted? Well, yes. Now we'll do negative 2x times 1, which is negative 2x. And again, we're going to plug it underneath here. It means negative 2x squared minus 2x. Again, we're going to subtract. because we want that first term to cancel each and every single time. Negative 2x squared minus negative 2x squared. Negative 2 minus negative 2. Well, really the negative to make a plus. And negative 2 plus 2 is 0, yes? So again, that first term canceled. We want that first term to cancel every single time. And we'll simplify the rest of the terms. 2x minus negative 2. Negative makes a plus. So 2x plus 2x is 4x. And we bring down the next term. Questions on any of this here? We kind of get the hang of this so far? It's really just a handful of steps that we do again and again and again and again. Because even at this point, we've got to do it again. And this time we're saying what times x gives us 4x? Well, the x's are already the same, yes? So all I'm missing is a 4. And since it's positive 4, it would be plus 4. So we're going to multiply 4 times our x plus 1. And our 4 times x is positive 4x. Is that the first term we wanted? Yep. And then 4 times 1 is plus 4. Giving us 4x plus 4. And last but not least, we would subtract. 4x minus 4x is 0, just like we wanted. And 8 minus 4 is 4, yes? And the last step, like before we bring the next term down, do we have another term? No. And this is also where it diverges or changes from long division with our numbers, is normally we can do decimal 0 and keep adding zeros. Here, we're done. There's no way to take it any further. And we will do something with that remainder here in a second. Any questions on what we've done so far? We kind of, I would not say full understanding, but we kind of get the idea of how this process works, yes? Okay. Any questions on how we got to our x squared minus 2x plus 4? Now we do have a remainder, yes? And we're going to add that remainder in. So if we have a remainder, we're going to put plus in our division bar. And put the remainder on top. And so our remainder here is 4. What were we dividing this by? It goes on bottom. Because we're saying this is what we have left over, and we've been dividing it by x plus 1. So the remainder is 4 over x plus 1. It's just our remainder, what we have left. And all that tells us is that this does not divide evenly. Now, if we got all the way to the end and the remainder was 0, we do not have a remainder, so what's over the bar here, it's just been x squared minus 2x plus 4 is the answer. So if the remainder is 0, we don't add it back in. Questions on this so far? It's not terrible, it's just tedious, monotonous. We're having to do the same process over and over again, yes? Synthetic division is a lot nicer. It's still going to be by hand, but it's a lot nicer than this. we're going to look at this next one here. So again, just like before, we're going to set it up. So we're going to have our house. Now, one of the things I didn't quite mention in the first one, which really didn't have an importance, is again, so we're going to divide this. So our 2x to the fourth plus 3x cubed plus 5x minus 1, it's going to go inside. Now, if there's terms missing, we have to add them back in. We can't have anything missing. So our first term is 2x to the fourth. So our fourth power is what we have. Then we have plus our cubic, our third power, 3x cubed. Yes? So we have our fourth power, our third power, plus what's our squared term? Do we have one? No. We need to add it back in. And we're going to add it back in as 0, because 0 times anything is 0. And the reason we do this is if you notice in the last one, each time we multiplied, every term lined up. Yes? Here, if we don't put that 0 squared, not 0 squared, 0x squared back in, we're going to have a mismatch. It's not going to line up. We do have our x term, which is positive 5x plus 5, excuse me, plus 5x minus 1. And our term on the outside is our x squared plus 3x plus 2. Okay. Questions on how we set this up? All right. We're going to start that process like we did all over again. So again, we want this first term to cancel out because we want to cancel it one term at a time. The first term is always going to cancel to 0. So our first main question is what times this first term out here, x squared, what do I need to multiply the x squared by to get 2x to the fourth? 2x squared. Because our 2 times 1 with the x squared will give us the 2. And x squared times x to the fourth, or x squared times x squared will give us our x to the fourth. And then we can do this multiplication off to the side and then put it underneath. And our first multiplication is going to be 2x squared times x squared. Well, our 2 times 1 is 2. X squared times x squared is x to the fourth, which is indeed our first term. We wanted 2x to the fourth. 2x squared times 3x. Well, our 2 times 3 is going to be 6. And x squared times x is going to be x to the third. And lastly, 2x squared times 2 is going to be plus 4x squared. And then we're going to put it underneath. 2x to the fourth plus 6x cubed plus 4x squared. Questions on this so far? And then what are we going to do? We're going to subtract all three. Now the first one, 2x to the fourth minus 2x to the fourth, 0. And that's what we want to have in each time. Now the rest can become 0 or they can become a number. It really doesn't matter. 3x cubed minus 6x cubed is negative 3x cubed. Since they both have x cubed, our answer will have x cubed. We're just subtracting the numbers. Next one, 0x squared minus 4x squared. 0 minus 4 is negative 4x squared. Because if we didn't add that 0, there's a high likelihood that you would have tried to take 5x minus 4x squared. We can't actually subtract those. So putting that 0 in does help us kind of space it out and make sure we do line up the like terms. Last step in the first step is to bring down the next term. And we're going to repeat this process again. So this time we're saying what times x squared gives us negative 3x cubed. Negative 3x. Negative 3x. And we're going to multiply through again. So the first thing we're going to do is negative 3x times x squared, which lo and behold does give us negative 3x cubed, because our negative 3 times the 1 is negative 3. X times x squared is x cubed. Negative 3x times 3x will be negative 9x squared. And lastly, negative 3x times 2 is negative 6x. Questions on any of this so far? And then the next thing we're going to do is to subtract. Now the first thing we're subtracting is negative 3x cubed minus negative 3x cubed. Negative 3 minus negative 3. The negative negative makes a plus, telling us we have negative 3 plus 3, which is indeed 0. First one becomes 0. Next one we have negative 4x squared minus negative 9x squared. If some of these negative negatives do have issues with it, we can do part of this in the calculator. Can't plug the x squared in, but I can plug in negative 4 minus negative 9. Here our negative negative would indeed make a plus x squared. And it would tell us that it is 5, so 5x squared. Next, we have 5x minus negative 6x. The negative negative would make a plus, so 5x plus 6x is plus 11x. And lastly, we bring down the, yes, you're good. Did you have 1x? Yeah, you're good. So it'd be negative 6x, so the minus negative 6 would give us a plus. And 5x plus 6x would give us 11x. Questions on this here? And lastly, what times x squared gives us 5x squared? 5. And since it is positive, we would put plus. We'll do this one more time. 5 times x squared plus 3x plus 2. We're going to multiply all the way through. So 5 times x squared is 5x squared. 5 times 3x is going to be plus 15x. And 5 times 2 is plus 10. Again, just like before, we'll have 5x squared plus 15x plus 10. And again, we're going to subtract. 5x squared minus 5x squared is 0. It cancels out just like we wanted. We want that first term to cancel. 11x minus 15x is negative 4x. Negative 1 minus 10, negative 11. We don't have another term to bring down, do we? So this is as far as we can take this. And because that remainder is not 0, we have to add it back in. We add to it, what was the remainder, our negative 4x minus 11, and put it over the top of what we've been dividing by, our x squared plus 3x plus 2. And that is really all there is for this long division. There's not a terrible amount of steps to this. it's just tedious and takes a while. Yes? Yeah. Yeah. Now, one thing I think is interesting, if you notice our first term that we put, so here x squared, I put it over the x squared, yes? The term after it had x, and the term after that was the constant. Really, if I line that first one up, it gives us our term. How many terms did we have for what we were dividing this by? 3. Okay. 1, 2, 3. So we started off over the top of the third term over, yes? Maybe that's a coincidence. Let's see here. How many terms were we dividing this one by? 2. 1. It kind of gives us a hint at what the first term's variable is going to be. Not so much the number, but it's going to start out as x squared. Questions on this so far? All right. So which part's confusing so far? How we start?
How we start this part, like how you find which one's term.
Okay, yes, how we find out which term it is. Yes, and that's normally where we get stuck. So we'll address it right here. So let's get this one started off. So we want to divide 4x to the fourth plus 5x minus 4. So our first term is 4x to the fourth, yes? So the next term we need is our x cubed, but do we have it? Well, no, so we have to add it in as 0x cubed. We don't have our squared term, so we have to add it in as 0x squared. Luckily, we do have our x term and our constant. So we start off with whatever variable has the biggest exponent. So x to the fourth, so we need it, x cubed, x squared, x, and our number. If any one of those is missing, we add it in with 0 times whatever that term is. Now, if it is the constant term, we just do plus 0. And we put what we're dividing it by out front. So x squared, 3x minus 2. Now, even if what's out front, so our x squared, if it was, say, x squared minus 2, we can write it as x squared plus 0x minus 2. We want all the terms there. Okay? Now, the question was, how do we figure out what we're multiplying by? Yes? So how we find that is I look at this here. So the first term we have is 4x to the fourth. I want it to cancel out because in each step we want that first term to cancel. And the way that we cancel it is with the first term outside. We have x squared outside, we have 4x to the fourth inside, yes? So let's look at the numbers in front. Outside, it's not written, but the number in front of x squared is. And we have our x squared. So the first thing I'm looking at is what times 1? What number can I multiply by 1 to get 4? 4. And we'll put it on top of this bar here. So let's see where. Now we need to see what times x squared will give us x to the fourth. So how many x's do we have outside? 2. There's 2 of them being multiplied together. Inside, how many do we have multiplied? Because a power is just telling us it's multiplied by itself that many times. So inside we have x to the fourth, so there's 4 of them. Outside we have 2. So how many am I missing? 2. So it would be x squared, or 4x squared, because our 4 will get that 1 to become 4, and that x squared will make the x squared outside match up our x to the fourth inside. Does that make sense? Now we also notice, well, I have 3 terms outside, yes? So if I go over 1, 2, 3, the term underneath is x squared, so we have our x squared, yes? Now the number on top, the 4x squared, we're going to multiply through our x squared minus 3x minus 2. To get this part here. So the first thing we're going to multiply is 4x squared times x squared. Well, our 4 times 1 is going to be 4. X squared times x squared. When we multiply like bases, we add the exponents, which would give us x to the fourth. Now we're going to do 4x squared times negative 3x. Well, 4 times negative 3 is going to be what?
Interruption. The following students please come to the office. Tristan Nash, Talon Ward, Tyler Elson.
Because our 4 times negative 3 would be negative 12. X squared times x would be x to the third. And lastly, 4x squared times negative 2. 4 times negative 2 would be negative 8. And we have our x squared. And again, we're going to subtract. Yep, and I wrote the wrong number there. Because it shouldn't have been 3. It needs to be 4. 4x to the fourth minus 4x to the fourth is 0. 0x cubed minus negative 12x cubed. The negative negative makes a plus. 0 plus 12 is 12x cubed. 0x squared minus negative 8x squared. The negative negative makes a plus, giving us plus 8x squared. And lastly, we bring down the 5x. Questions on this so far? Are you ready for the next part? Okay, we're going to do this again. We need to see what times x squared will give us 12x cubed. What times our 1 gives us 12? 12. And it would be positive, so we can say plus 12. Now we need to see what do we multiply by x squared to get x cubed. I have 2 outside, I have 3 inside. It's just x. And really, once we get that first one set up, so x squared, the next term will have x, and the last one's just going to be a number. So we're going to take 12x and multiply our x squared minus 3x minus 2 by it. Now our 12x times x squared is going to be 12x cubed. It's going to match up just like we want. 12x times negative 3x is going to be negative 36x squared. And lastly, 12x times negative 2 is negative 24x. And again, put it underneath. 12x cubed minus 36x squared minus 24x. And again, we're going to subtract. 12x cubed minus 12x cubed is 0. 8x squared minus negative 36x squared. Well, the negative negative would make a plus. 8 plus 36 is 44x squared. 5x minus negative 24x. Negative negative make a plus. Plus 29x. And lastly, we bring down the minus 4. Because we're minusing, yes. Lastly, what times x squared gives us 44x squared? Plus 44. And again, just like before, we're going to distribute through. So we're going to do 44 times x squared, which lo and behold is 44x squared. 44 times negative 3, well, negative 3x. Can't do that all in the calculator, but I can do negative 3 times 44. 132, and we can put the x back in. And lastly, 44 times negative 2 is negative 88. And then we're going to subtract again. 44x squared minus 44x squared is 0. We cancel that out. If any of the other terms in this expression, the x term became 0 or the constant term became 0, we'll still put the 0 in. Won't leave it in our answer, but we can put it back in. 29 minus negative 132. Negative makes a plus. 161x. And negative 4 minus negative 88. Negative makes a plus. And this plus 84. Questions on this here? How do we feel about dividing? Long division. We feel good with it. It's a little not a little, it is tedious. But it is, once we get a hold of that process that we're doing each and every time, it just repeats. It's just the process itself. So we feel comfortable with this here. We're going to do one more, and then we are done for today. And we're right about there. And it's this one here. And the reason I want to do this one here is right there at the end. The reason I want to do this one here is I want to show you guys one that actually gets a remainder of 0. So the inside, we do have the x to the 4th, but we don't have our x cubed, so we have to add it back in as 0x cubed. We have our x squared, so plus 4x squared. Don't have x, plus 0x, minus 45. Now what times x squared gives us x to the 4th? Not a number in front, so it's just going to be 1. How many x's do we have outside? 2, because it's x squared, yes? How many do I have inside? 4. So how many am I missing? 2. So we're going to have to multiply it by an x squared. And since the number inside's 1, the number outside's 1, it's just going to be x squared. So we're going to come over here and say x squared times x squared plus 0x plus 9. So x squared times x squared is x to the 4th. Yes? X squared times 0x squared plus, well, 0x cubed. Yes, it is 0, but we still want that placeholder. X times x squared is going to be x cubed, and we have 0. And lastly, x squared times 9 is plus 9x squared. Now the first term will cancel. X to the 4th minus x to the 4th is indeed 0, yes? 0x cubed minus 0x cubed. It would also be 0. We could drop it. I'm going to leave it just so we keep track of our terms. 4x squared minus 9x squared is questions on this so far? Okay, we're going to repeat the process. What times x squared gives us 0x cubed? Well, we know we'll need an x, yes? And our number would be 0. Because the only way I can multiply x squared and get 0x cubed is 0x. Well, wait a minute. This one's the kind of funny one. Yes, because 0x cubed plus 0x squared plus 0x. So really, we could have just crossed that out and brought the next term down. That's really what we're doing. I'm going to keep with my color scheme. Because our x cubed minus 0x cubed minus 0x cubed is indeed 0. Negative 5x squared minus 0x squared. Well, negative 5x squared. 0x minus 0x is still, well, 0x. So could we have just crossed that x squared out, or x cubed out? Yeah. But we wouldn't have brought one term down, we would have brought 2. Or we can do this here. Questions on this here? What times x squared gives us negative 5x squared? Negative 5. We're going to multiply through. So negative 5 times our x squared plus 0x plus 9. Now negative 5 times x squared is negative 5x squared like we want it. Negative 5 times 0x is going to be plus 0x. Negative 5 times 9 is negative 45. And we're going to subtract, yes? Before we start subtracting, are there any other terms to bring down? No. So we're going to just start canceling things out that cancel out to 0. Negative 5x squared minus negative 5x squared is indeed 0. They do. 0x minus 0x is 0. I don't have anything else to divide by, so we can keep crossing out zeros. Negative 45 minus negative 45 is 0. The whole thing became, yep, negative 45 plus 45 is 0. So our remainder is, so this is our solution. Or we can say it's just x squared minus 5. Because any of those 0x's we can throw out. We just needed them for the process. And that's it. 6 problems. 5, 6, 7, 8, 9, 10. And synthetic division is nicer than this. And it's about a third of the time.